Rice is the fundamental lifeblood of global agriculture. Across the world, it thrives in lush, water-rich paddies. For over half of the human population, rice is not just a crop, it is a daily necessity. But the path from the flooded field to the kitchen table is a complex, months-long agricultural journey. The rice growth cycle begins in the nursery bed. This is a small, controlled plot where rice seeds are sown densely to ensure protection and focused care. By planting them in a compact space, farmers provide an optimal environment for germination. Over the course of several weeks, these seeds sprout into healthy, green seedlings. This nurturing phase is critical as it prepares the young plants to withstand the conditions of the main field. After the nursery phase, the seedlings are ready for transplanting. This involves moving young plants from the crowded nursery bed into the open, prepared paddy field. The goal is to provide each plant with optimal room for growth by placing them in neat, even rows. Traditional manual labor involves hand planting seedlings. This is skill-intensive but precise. Modern mechanical transplanters can perform this task at scale, ensuring consistent spacing and efficiency. Despite the method, the objective remains the same, creating the perfect foundation for high yields. Flooded fields, or paddies, are an engineering marvel of nature. Standing water provides a unique environment that dry field farming simply cannot replicate. First, the standing water acts as a natural weed suppressant. It creates a physical barrier that prevents light from reaching unwanted seeds on the soil surface, preventing them from germinating. Second, water regulates the soil temperature. Because water has high thermal mass, it buffers the roots against drastic shifts in air temperature throughout the day. Finally, the flooded state allows nutrients to dissolve and reach the root zone directly. This efficient uptake is essential for high-yield rice production. By managing water levels, farmers maintain the perfect conditions for their crop to thrive. The seedling phase is the next step in development. Early development phase. The tillering phase is the next step in development. Expansion and branching. The flowering phase is the next step in development. Reproductive stage. The ripening phase is the next step in development. Grain maturation. This 3 to 6 month cycle transforms a tiny seed into the staple crop, feeding billions. Water control is the most skill-intensive part of rice farming. Farmers must constantly monitor and adjust the water level to prevent weed growth. If there is too little water, weeds compete for nutrients, causing stress to the rice plants. However, farmers must also drain the fields at precise intervals. Too much water for too long can drown the roots by depriving them of oxygen. At the peak of its vegetative growth, the rice plant directs its energy toward reproduction. A flowering head, known as the panicle, begins to emerge from the top of the stalk. This panicle is the structure where individual rice grains develop. Initially, the plant remains a vibrant green, focused on building the framework for the future harvest. As the plant reaches maturity, a significant transformation occurs. The grains begin to fill out with starch, and the plant's color shifts from deep green to a rich golden brown. This golden hue signals that the grain is reaching full maturity. The transformation from green stalks to golden panicles marks the final stages of the life cycle, preparing the plant for the upcoming harvest. Mechanized harvesting has revolutionized rice production. The combine harvester performs 3 complex tasks in a single pass through the golden crop. First, the header cuts the stalks. Then, the threshing mechanism beats the grains loose from the panicle. Finally, it separates the heavy grain from the lighter straw. These integrated steps ensure maximum efficiency, turning standing stalks into collected grain ready for transport. Once harvested, the rice grain is referred to as rough rice or paddy rice. At this stage, each individual grain remains fully enclosed within a tough, fibrous outer layer known as the hull or husk. This outer husk acts as a natural rugged shield. Because it is highly fibrous and tough, the rough rice is inedible to humans in this state. It must be processed to reach the nutrient-rich seed inside. In the next steps, we will see how milling removes this protective husk, preparing the rice for consumption. After harvest, rough rice is transported to industrial drying facilities. Freshly harvested rice contains too much moisture for safe, long-term storage. In the dryer, warm air is circulated to reduce the grain's moisture content. The goal is to reach a precise target of 14%. We must carefully balance the moisture. Too much moisture encourages mold growth, but drying the rice too much makes the grain brittle, causing it to crack during milling. After drying, the rice is moved to massive storage silos. These structures protect the grain from pests and moisture. By maintaining strict control over temperature and airflow, these facilities can preserve the harvest in optimal condition for many months. This storage allows producers to supply mills throughout the year, matching the constant demand of the market. We now arrive at the milling facility, the industrial heart of the rice supply chain. This is where rough rice, freshly harvested and stored, undergoes its final transformation. Inside this facility, the protective but inedible hulls are carefully removed, and the grains are polished to become the white or brown rice ready for store shelves. This process balances the removal of exterior layers with the retention of vital nutrients, ensuring the quality and consistency expected by consumers everywhere. The first step in processing rough rice is hulling. Rough rice consists of the edible kernel protected by a tough, fibrous outer husk. Inside the huller machine, mechanical rollers strip away this coarse exterior. The husk is separated and removed as waste or a byproduct for other uses. What remains is the inner grain. Because the nutritious bran layer is still attached to the endosperm, this is known as brown rice. Brown rice is technically ready to eat, but most consumers prefer it further processed into white rice. After hulling, we have brown rice. The bran and germ layers, rich in nutrients, still surround the starchy core. To produce white rice, the grain enters a polishing chamber, featuring abrasive rollers. As these rollers rotate, they gently rub away the outer bran and germ layers. The result is the polished white endosperm, which is the soft, starchy center we identify as white rice. The choice between brown and white rice is a trade-off between nutritional density and food stability. Brown rice retains the bran and germ, which are packed with fiber and essential oils. These oils, however, oxidize quickly, causing the grain to go rancid. Polishing removes these layers, stripping away the bran, but significantly increasing the shelf life by eliminating the volatile oils. This processing ensures that while we lose some nutrients, the rice can be stored safely for much longer periods, a critical factor for global distribution. Optical sorting is a critical final step in rice processing. Here, rice grains pass under high-speed cameras that scan every individual kernel. The system instantly identifies foreign materials, broken grains, or discolored kernels. Precision air jets then blast the detected items out of the flow, ensuring that only the highest quality rice reaches the final stage. This automated process delivers consistent, high-purity rice, maintaining strict quality standards before packaging. After milling, rice must be graded. The process categorizes grains by size, uniformity, and quality to ensure consumers receive a consistent product. Advanced machinery separates the rice into different tiers. Whole grains, which are the most valuable, are separated from broken kernels. Uniformity is key. Standardized grading systems, like those used by the USDA, measure the percentage of broken kernels, color defects, and chalkiness to determine the final grade. This quality control process ensures that every bag on the shelf meets specific commercial standards, providing the texture and cooking quality consumers expect. Once the rice is polished and graded, it moves to the automated packaging phase. Here, a steady flow of grains is directed from overhead hoppers into high-speed weighing stations. Sensors ensure that every bag receives the exact required weight, maintaining consistency across the entire production line. After weighing, the rice is funneled into durable food-grade bags. Automated machines then heat seal the tops to preserve freshness and block out moisture. Finally, the system switches between retail-sized units and massive bulk wholesale sacks, preparing the product for transport to markets worldwide. Once processed, rice leaves the mill, beginning its journey through a complex global logistics network. Large quantities are moved by shipping containers, trains, and trucks to regional distribution centers. From these hubs, smaller fleet vehicles deliver the rice to local grocery stores, bringing the finished product to your shelf. This intricate chain of transport ensures that rice remains accessible staple for households across the globe. While most rice follows a direct milling path, some varieties like parboiled rice undergo an extra step. Before the hull is removed, the rough rice is soaked and steamed under pressure. This process forces vitamins and minerals from the outer husk directly into the endosperm. This unique steaming ensures the rice retains much higher nutritional value than standard white rice. The resulting parboiled rice is tougher, less prone to breaking during milling, and significantly more nutritious. It represents a vital variation within the standard manufacturing cycle. The journey of rice is a complex transformation. It begins in the nursery, where seeds are nurtured. Next is planting. Next is growth. Next is harvest. Next is milling. Next is distribution. From the controlled flooding of fields to mechanized harvesting, drying, and precise industrial milling, every step ensures quality before reaching global markets. From the flooded paddies to the sophisticated mill, we have witnessed how rice remains the cornerstone of human civilization, nourishing billions and bridging ancient traditions with modern technology. If you enjoyed this behind-the-scenes look at the science and craft behind your favorite foods, please like, share, and subscribe to our channel. Your support helps us continue exploring the processes that shape our world.